Okay. Uh, Thanks for the introduction, Philip. My name is Paul Albertella, and I'm the chair of the OSEP working group, and I work for Codethink. Let me see if I can figure out how to move this now. Oops. Uh, Apologies. There we go. So, what is the OSEP working group? It's the Open Source Engineering Process Working Group, and we're looking at two related questions, which is, first of all, can open source software projects like the Linux project apply the kind of processes that are expected by safety standards? Because as Philip said, there's a whole set of standards, some generic ones and some tied to particular industries that provide a kind of a guideline for about what kinds of processes and evidence you need to see if you want to make a case about software being safe or software as part of a system being safe. Um, so that there's, can we apply these to open source projects? But also, when we're making a system that where safety is important, can we apply these processes to open source when we're using it as part of those that safety related system? And also that applies to the kind of tooling that you're using as part of those projects as well. So our goal as part of ELISA is to create reusable resources for use by safety projects involving Linux. And as we'll see in some of our later slides, I think we're focusing mainly on projects about safety using open source rather than open source projects trying to be safe. We've historically in the OSEP group focused a lot on safety analysis and argumentation, which is asking sort of three questions. First of all, what value can Linux add as part of a safety application? Or why would we want to use Linux in a safety context? And what are the risks involved in that? How can we better understand the roles that Linux may have in such use cases? So what properties of an operating system are important, and how does Linux actually fulfill those roles effectively? And then, given that we've identified these some value and some understand the risks and understand the roles, on what basis can we argue that Linux is actually suitable for use in such a role? Which is, as Philip was saying earlier, how do we show that Linux can be used safely rather than arguing that Linux is universally safe? Now, our discussions and topics that we cover in the weekly meetings are frequently more wide ranging than this. We do get into technical topics such as Linux memory management and kernel self-protection features, which are related to the things that we're asking. And you can see on the GitHub repository that there are a number of pull requests in progress adding documentation around some of these. But we also discuss the kinds of methodologies, what we mean by quality, talking about the standards themselves, and also just talking about general software engineering principles and how those actually contribute to the whole safety picture. So just looking at some of the topics and things that we've focused on in 2025 to give you an idea about where we are and what we've been thinking about. The first one is the one I was talking about, which is, can we really expect free and open source software projects to comply with safety standards? And this is always challenging because of the nature of open source projects. They are not like product projects where you have a particular goal and you have an organization that's has a command and control over what the people are doing, what the goals are, how you decide whether you've got there. They're very much emphasizing collaboration and contribution. That doesn't mean they don't have some good and often rigorous software engineering processes, but it's hard to enforce that, and it's particularly hard to enforce that towards a kind of clear goal, such as we want it to be safe. So the conclusion that we've reached, particularly in OSEP, but I think more generally in ELISA over the years, is it's not reasonable or realistic to expect Linux to actually fulfill the requirements of the safety standard. We in a previous working group, we spent a lot of time looking at what processes are applied to the Linux kernel and how those do map to the kind of expectations the standards have. But I think we can't completely fulfill those requirements. And in particular, we can't expect projects that don't actually have a safety focus to imply those processes as they're expected by the safety standards. So this is what brings us to this idea of using Linux safely rather than arguing that Linux is safe. And what this really fundamentally boils down to is making an argument for a system that has a safety focus, that wants to use Linux or needs to use Linux, as to how we can argue that Linux, using Linux with the role that we understand for Linux in that system, that it actually satisfies a safety case. And that really means understanding what risks are involved in using Linux in that role. So how do we manage those risks, but also balancing that against how it contributes to the objectives of whatever the system is. And if we can find ways to address some of the risks that we identify, we can contribute solutions and enhancements upstream to the Linux project to address those specific risks or limitations. And if we can actually identify process type things that would be useful more generally, then we can try to encourage the Linux project to adopt those. But we can't force them to do it, and we can't realistically expect them to do it unless we can show them there's actually some value in it. And we can also use other open source and open projects. And one I'm involved with is the Eclipse Trustable Software Framework project, to complement how we're using safety standards in these contexts. Because one of the challenges with trying to apply safety standards to open source is that they're written with a different type of project, but also with different types of and expectations about software in mind. So actually making the transition to I'm applying this to open source software as opposed to I'm applying it to dedicated proprietary single purpose software is can be a challenge. So using these projects like the Trustable Software Framework and ELISA, the kind of approaches that we can develop can help us to work out how Linux can be part of a safe system. Another big focus for us has actually been trying to publish peer-reviewed material. So to make resources available that people can have some confidence in. They can see the processes that we've gone through in creating them. They can see that they have actually been reviewed, that we've actually had a process of thinking about them and questioning them, so that you can actually then treat them as something that's a good basis for you using in your own work. As part of that, we have a kind of a set of criteria for evaluating open source documentation, which is as part of the OSEP documentation site. And we also kind of came up with a way to provide user-friendly documentation in the form of a website rather than just files in a Git repository. And you can see this on the ELISA directory, and you can also see it on the OSEP site as well. And one of the things we really wanted to do in selecting and reviewing these kinds of resources is to actually establish a basis for the kinds of claims or assertions that we want to make about Linux. If we're saying Linux is suitable for safety with these limitations, then we want to actually some basis for that. And part of our approach there is to come up with repeatable research or investigations. In other words, if we're saying, well, if you use these configurations of Linux, then you can actually have a way to detect or minimize memory corruption, then we want to say, well, on what basis are we making that claim? How can you take what we're saying, go away yourself, and convince yourself that that our conclusions are correct? And documenting the source of information that we've used in writing that document as well is another important thing. This is an open project. We want people to be able to not only recreate the investigations that we've done, but also to confirm them. So this is a kind of a basic part of the approach we want to take. So making those objectives, this idea that it needs to be repeatable research or an investigation that's clearly specifying what it's trying to do and documenting the source of information that are used needs to be part of the review criteria as well. Now, you'll hopefully think this isn't too surprising and really describes how research, particularly scientific research, is intended to be carried out, but it's useful to be clear about these things. What do we have planned for 2026? Fundamentally, it is, can we actually review and publish more material? At the moment, we have quite a lot of material that's been contributed, that's in the GitHub repository, but it hasn't actually been through this peer review process yet. So we have a number of pull requests that are in flight, so to speak, and that would very much benefit from review and editorial input. Making that process happen when you have people who are participating in ELISA around their day job, so to speak, can be a challenge. But that's one of the reasons why we want to be able to do it in a forum where people can have their input and contribute as and when, rather than having tying them to a particular timetable. The other thing that's come up a great deal in our discussions and in wider ELISA discussions over the years is we've discussed lots of things. We've come to conclusions, but we also have some unresolved questions. And actually being able to write about what has been discussed and where we do have some consensus about an approach or about things that limitations about what we can do, actually documenting that and making it clear so that new people wanting to participate in ELISA can get up to speed about where we are and why and the rationale about the conclusions we reached. Where we have tried particular approaches as well, it would be really useful to write about them, what we learned from them if they didn't go the way we expected them to, but also what wasn't tried, what could be carried forward, and also because there will always be differences of opinion about a particular strategy or what works. It's important for us to actually acknowledge those, be able to express the various perspectives that exist, so that if we do want to reach some consensus, we know what the different inputs to that are. And we'd very much like to explore new topics. So new participants and topics for discussion are always very much welcome. And you can join in the weekly meetings, which are on Thursdays at 2:00 UTC. You can see the calendar for more details on that. Please join the mailing list as well. Always happy to have discussions and answer questions on the mailing list too. We have a presence on the Discord server, so you can just ask general questions in the general chat, or if you want to pose particular topics for us to discuss elsewhere, then there's a topics channel too. You can have a look at the documentation that we do have and review the pull requests that are in flight, and reach out to us. We are a friendly group. Please feel free to get involved. Now, I've rattled through that quite quickly, but be very happy to answer any questions.
If you have any questions, raise your hand and I'm happy to unmute you.
And
Or
I'm
you can
also looking
also,
at the chat if you wanted to
yeah.
type them instead.
Yep.
Okay, there's a general question, not only to the OSAP part, but it fits to a good
Abs
extent.
Absolutely. So how can Linux be used in automotive safety projects? Okay, so when you say your more focus is more about architecture, so does that mean you want to understand more about the Linux architecture, or does that mean that you want to um, understand how it fits into an automotive architecture?
I hope you can hear me.
Yes.
Hello.
Yes, we can hear you.
Great. So yeah, I work in automotive domain and
Hmm.
work with high HPCs really long time now. Have used proprietary, I would say high level operating system, QNX, GHS, all those sorts. And I'm very much interested to know in those terms as Linux is like monolithic architecture in general itself.
Hmm.
So it occupies everything together with the kernel, everything shares the same address spaces. So when we talk, I saw that you're not guaranteeing that it's about a safe Linux, but about you using it in that context. So technically, I really want to understand, for example, any kind of memory faults or any kind of an isolation strategy. How then ELISA work? Like, does it define a specification to handle this in the Linux environment?
That's a,
What's overall means how we proceed with Linux in that use
that,
cases?
that that's a great question. So yeah, one of the things that we have discussed in OSEP is this kind of question. It's how do we make an argument about Linux if we're going to use it in, for example, automotive, and that involves identifying what kinds of things people need to know when they're coming to this. So, for example, we have a document by one of our participants, Igor Stopper, which talks about what types of technical level risks do you need to be aware of associated with using Linux. So you talk about the monolithic architecture and address a different kind of having a shared address space. There are some really useful aspects of the Linux memory model and the process model, which means that you can have some confidence about separation between different processes and them not being able to trample over each other's memory. But there are also some limitations that you need to be aware of, and there's various strategies, configurations for the kernel which you can use to deal with some of those. But there's also some aspects that are more difficult to address. So yes, if you want to visit the site and have a look in the contributions section, that's a good place to start for understanding that. And that's the kind of documentation we're wanting to get reviewed. So if you could give us some feedback on that, for example, that would help us to say what do we need to do to make this documentation fit for us to publish as some general advice and general guidance for people to use.
It will be great. Means if that's my whole intention to join here. I'm also a great supporter for open source, but I
Hmm.
work in automotive and it's very proprietary driven, and I would like to understand also share my knowledge. And because as I said, I worked in this domain really long, so I would like to see what kind of specification and proposals are in an ELISA. And yeah, I can also give a feedback how generally it is expected from an OEM, what level of, I would say, protections, example, in terms of isolation, what is an expectation? Does it
Yes.
satisfy? What are the limitations? Yeah, so how could then I reach here in ELISA? Is there any website or some, I would say, some GitHub where I can start looking into the documentations in a more organized way? Or is it divided into working groups? Because I'm a bit confused with the working groups. I'm part of the architecture working group, although I have
Yeah.
never got time to join. But I am trying to understand when we say OSS, what it focuses on, what architecture focuses on, where, in which, who provides the repo for these specifications to review. Some
Yeah.
highlight will be really helpful.
Yes. And I think this is again, this is something that we have been trying to address by having this a website where you can go to a sort of central place to say this is where the information you can find the information, and this is where you can find the ongoing work in this respect. As I say, the set of I think starting from the ELISA sort of landing page will direct you to where you can find the working groups. But I'll put in the chat a link to the document I was talking about, so you can look there. And I think my slides will also get published after this as well, so you can follow the links to the various OSEP pieces too.
Thank you. Thanks a lot.
No problem.
And then you also will later see, so it's not only about direct guidance, but it's also about of education. So in the last session, there's the Linux features part from Alessandro, where last year he also looked into like a minimal configuration for a kernel. What does this mean? Or how to deal with certain devices, character devices, or whatever. Look into memory parts that you get a better understanding. I think this can also be a base to bring you forward. And then it also, of course, heavily depends on the use case. If you're able to detect potential errors which can happen, let's say there would be a memory corruption, it could mean that you're not affected. Alessandro, just speak up here.
Yes, just complaining that if you say everything in my place, I have nothing to say in the next annual. Just this.
Not saying much more than teasering what you will tell.
Okay, great.
And right.
Actually, I also have some, like, as I said, I'm also like very looking forward for this OSS. I also have some of my proposals how we can achieve this with the Linux kernel. So it would be great to collaborate on that.
Yeah, and I think it's very good to have this in. And I can honestly say with the member companies of ELISA, we have also various approaches how to face this challenge. And the wonderful thing is, even if architectural considerations, approaches, concepts differ, we're still can jointly work together towards the same goal. And this helps you really to get a good understanding on how the one or the other aspect works. And I guess this will also come clear over the next sessions, which we have.
Yep.
Wonderful. Which brings us basically enough time for a last question, or stop the recording a minute early and then just move on to the systems and automotive workgroup update. Okay, I guess then I would stop the recording.